68 divided by 125. Where's the fun in just putting that in the calculator? It's no fun. Maybe you'll have other fun, but you won't have fun with math. We can divide 68 divided by 125. Doesn't go in, 0.0, 0 times, decimal point up. 125 goes into 680. 125 and 125 would be 250, and then 375, and then 500, so times 4 is 500. I'm just going to start with a times 6, see how that goes. Carry the 3, 5, carry the 1, 7, 750. Well, that's too much. Did I do it right? Yeah, I did. That's too much. How about 125 times 5? Carry the 2, the 1, 625. That'll do it. We continue. Subtracting. $55, give ourselves a 0, bring it down. 5's too much. What's 125 times 4? Carry the 2, 8, plus 2 is 10. 500. That was 4 times. Subtract, we get 50. Bring down the 0. And it terminates. Do 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 do. Do 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 do. 0.544. That means tenths, hundredths, thousandths. These are equivalent fractions. There is some number, specifically 8, that gets us to our number. But we didn't need the trick. If you got the trick, great. Division got us there. Round to the nearest hundredth. .3 with a repeating bar over the 3 is about what? Well, if we start actually writing out the repeating part, tenths, hundredths look to the right. It doesn't bump it up because it's not 5 or greater. So rounded to the nearest hundredth, 0.33. But that is approximately. It is about 0.33. It's not exactly. The repeating form is exact. $17 80ths. Again, nearest hundredth. 17 divided by 80 goes in 0 times. Give a 0.0, bring the decimal point up. 8 and 8 is 16, so this goes in twice. 160. Subtract, we get 10, give a 0, bring it down. 80 goes into 100. Once, 1 times 80 is 80. Subtract, we get 20. Give a 0, bring it down. 8 times 2 is 16. So this is 1/60th or 160. Subtract, we get 40. Now that 2 repeated, but we got a completely different Completely different answer when we subtracted 160. So this is not going to be a repeating decimal. The subtraction is going to be different when we use this two. Give ourselves a 0, bring it down. Do we need to continue? Absolutely not. Nearest hundredth, so it's about equal to 0.10ths hundredths. The thing to the right of this second digit tells us whether or not we round up. We didn't even need to do 2 times 80. We did not need this. It's true if we wanted to keep going and get more digits, but all we needed to know is that it went in twice. We just needed to know that 160 was the highest. We didn't need, so maybe I'll correct what we didn't need. We didn't need this actual 40. We didn't need to bring down another 0. So since this doesn't round up, nearest hundredth, 0.21. Let's round to the nearest tenth. .07 repeating. Well, here, we don't even need to know that this would be the 0.070707. It's sure nice to know. But since we want the nearest tenth, we already see this is 5 or greater. So it's about 0.1. Nearest tenth, the rounded number needs to end in the tenths spot. So let's compare some decimals. 0.252, 0.251. We did this before. No issues. Same, different. 2 is greater than 1, so greater than. Okay, 0.485 and 97 200ths. Why couldn't it stay easy? So we've learned how to compare fractions and we've learned how to compare decimals. What happens when we have to compare a fraction with a decimal? Well, when they're mixed, we need to make them both the same. And it's easier to just go ahead and divide the fractions, write them as decimals, and then compare the decimals. So if we wanted to compare 0.125 and 1/4, we would divide 1/4 or multiply top and bottom by 25, giving us 25 100ths. Either way, we get 0.25. And just compare 0.125 with 0.25. We see that that's less than. We can't compare unless they're both the same thing. It's going to be easier to turn this into a decimal. So let's do it. 97 divided by 200 goes in 0 times, so 0.0, bring the decimal point up. 200 goes into 970 4 times, 800, 170 left. Same, keep going. Give ourselves a 0. Bring it down. 2 times 9 is 18. That's going to be too much. 2 times 8. So we need 8 times 200 to give us 1600. Oh, I'm in the way. Rewrite this up here where I'm less in the way. Subtract. Give ourselves a 0, bring it down. 200 goes into 1,000 5 times evenly. Oh, wow. 0.485. They're the same. Equals. Not greater than or less than. Equals. Zero 0.0912 and 9 hundredths. Well, this is nice. 9 hundredths, tenths, hundredths, the number 9 ending there. Let's compare. Same. Same. Different. What would be here? A 0. It's different. 1 is greater than 0. Greater than. .7 repeating and 2/3. Fractions is easier here, in my opinion, because we have the 9 trick. 0.7 repeating is not 7/10, it would be 7/9. And 2/3, that's 6/9. 7 is greater than 6. But you could also change them both to decimals and get that 2/3 is 0.6 repeating, same, different, greater than. So you can compare them both as fractions, you can compare them both as decimals. You got to move them one direction or the other. That's what makes these beautiful. One direction. I'm only like 95% sure that that was an actual joke. $47.98. And 0.473 repeating with just the 3 under the repeating bar. That means, in case we need this, it is 0.4733333, and the 3s repeat forever. I don't want any part of turning this decimal into a fraction. No part at all. So let's turn this fraction into a decimal. 47 divided by 98. Goes in 0 times. Give ourselves a 0.0. Bring the decimal point up. 98 goes into 470. I'm going to guess 4 times. 98 times 4. 4 times 8, because it's close to 100. 4 times 8 is 32. Carry the 3. 9 times 4 is 36, plus 3 is 39. 4 times is 392. Another close to 100 is definitely going to push that over 470, so it's not 5. Subtract. So far it'd be the same, so we have to keep going. Borrow. Borrow. Give ourselves a 0. Bring it down. I'm going to keep with my strategy. That's about 100, so I'm going to guess 7. 98 times 7, 56, carry the 5, 63 plus 5 is 68, 686. Another 98 would be 100 minus 2, 84, that'd be too much. So it is going to be 7, 686. Subtract. $94, we're good. It's less than 98. Give ourselves a 0, bring it down. Still the same, we have to go on. 98 goes into 940. I'm going to say 9 times. 10 is too much and impossible, because that'd be 980. So 9 times. Before we do 9 times 98, we can stop. We have 0.479. This was the same, this was the same, but the 9 and the 3 are different. The 9 is greater than the 3, greater than. We didn't have to keep going. But we did need to do that much work to be able to confidently say that it was greater than. $1/11. And 0.1. Now, this one's 1/10. Remember, in order to compare, they have to both be fractions or both be decimals. Here, they are both fractions, but since they don't have the same number on the bottom, we would have to go times 10 over 10 here, times 11 over 11 here. This is 10 1/10. This is 11 1/10. 10 is less than 11. That less than goes all the way up to the problem. It is less than. Notice, 11 being greater than 10 did not make this greater than. Once we were able to compare with a common denominator, we saw on the tops that it has to be less than. So there'll be a lot of examples where we're putting greater than, less than, or equal in between. There will even be some problems where you'll be given a list that has fractions, decimals, and you'll have to put them in order from smallest to largest. So lots of practice converting and comparing. So to compare 1/2 and 0.54, we would turn 1/2 into a decimal, which is 0.5. You shouldn't even need any work for that. 1/2 is 0.5, 5/10. And then we compare. We'd imagine 0.5 is 0.50 and 0.50 is less than 0.54. Now let's take a look at 0.5 repeating and 5/9. That repeating means that this is 0.555555555 forever and ever and ever. 55555. Let's divide 5/9. Write 5/9 as a decimal. Well, 5 divided by 9. 9 would be on the outside, 5 would be on the inside. 9 doesn't go into 5, but 9 goes into 50. So we'd start with a point, and then 9 goes into 50 5 times. And 5 times 9 is 45. 50 minus 45 is 5. Give ourselves a 0, bring it down. 9 goes into 50 5 times. 5 times 9 is 45. 50 minus 45 is 5. Give ourselves a 0, bring it down. We've started to repeat right off the bat. 5/9 just so happens to be 0.5 repeating. So when we compare 0.5 repeating with 0.5 repeating, we see that they are equal. So these are equal. In general, if we had 0.5 without the repeating bar, it would be 5/10. To turn it into repeating, we knock one off the denominator from 5/10 to 5/9. And that's how to turn any repeating decimal into a fraction. Say it without the repeating part and then subtract 1 from the denominator. So repeating decimals are fractions with denominators 9, 99, 999, so on and so forth. Next, we're going to write the numbers in order from smallest to largest. Well, in order to do that, we need to know which one's the smallest and which one's the largest. The middle will take care of itself at that point. And we're going to need to write the fractions as decimals. So if we divide out 1/3, we get that that's 0.3 repeating. 0.302, that's just 0.302. If we divide out 3/8, 3 divided by 8, that gives us 0.375. Again, feel free to pause and try any of these divisions on your own to make sure that you get the same decimal. Division is important. Being able to divide is important. So 0.3 repeating, that's 0.33333. So they all start with 0.3. The second digit then would be 3, 0, and 7. So from smallest to largest, the one with the 0 second would be first, the one with the 3 second would be second, and the one with the 7th second would be third. 0, 3, 7. First, second, third. So writing them in order, we would have to go back to their original forms, the actual numbers that we were told to write, and we would go 0.302, 1/3, 3/8. So now that we know how fractions and decimals interact with each other, we can review order of operations and then tackle any example with decimals, any example with fractions, any example that's mixed. Recall, PEMDAS, please excuse my dear Aunt Sally, 4 stages. Parentheses, grouping symbols. Then exponents. Then in the third step, multiply or divide in order as we come to it from left to right. And then the fourth step, add or subtract in order as we come to it from left to right. Here we just have division and multiplication. We know it's PEMDAS. We know that even though the M comes before the D, that is in the same step. So left to right, as we come to it, we would have this division first, then the multiplication. So 897.8 divided by 100 would move the decimal point 2 to the left. So 8.978, and then times 10 moves it back 1 to the right. So 89.78. We don't even have to do anything more than move the decimal point from left to right when we multiply and divide by 100 or 10 or 1000, those powers of 10. Negative 8.69 times, in parentheses, 3.2 minus 1.8. PEMDAS says work inside the parentheses first. 3.2 minus 1.8, line up the decimals, subtract, put the decimal point in the same part, in the same spot of the answer. We get 1.4. Then we want to multiply. Negative 8.69 times 1.4. Negative times positive is negative. Write it as a normal multiplication problem, 869 times 14. Multiply and make sure that there are 1, 2, 3 spaces after the decimal point. Negative 12.166. So this is a great review of operations on decimals. Let's simplify. In parentheses, negative 2.3, and that's squared, plus 4.1 times, in parentheses, 2.2 plus 3.1. Let's simplify inside the parentheses first. 2.2 plus 3.1 is 5.3. Then take care of the exponent. Negative 2.3 with parentheses squared is negative 2.3 times negative 2.3. That would be positive 5.29. We have addition, we have multiplication. Multiplication comes first. 4.1 times 5.3 is 21.73. Again, feel free to pause and work these out. Make sure you're getting the same answers. Finally, we add 5.29 plus 21.73, and we get 27.02. $20.06 minus 1.2 squared divided by 10, all over 0.02. So at the end of this, we're going to divide by 0.02. Let's simplify the numerator before we divide. We're going to go ahead and square the 1.2. That minus is outside the parentheses, so it stays minus. 1.2 times 1.2 gives us 1.44. We have subtraction, we have division. Division happens first. Dividing by 10 is moving the decimal point 1 to the left. So from 1.44, we get 0.144. And now we subtract 20.06 minus 0.144. Line up the decimal point, fill in a placeholder 0, so it's 0.060. When we subtract, we get 19.916 over 0.02. So finally, we're dividing. We would have to move the decimal point 2 to the right so that we're dividing by a whole number, so that we're dividing by 2. That would be 1,991.6 divided by 2, which is 995.8. So feel free to check any of those
operations with decimals. The more practice you get, the better. It's not 6 steps. It's 4. Parentheses or any grouping symbols first, then exponents. Multiplication and division from left to right as we come to it. Until that's all gone, then all that's left is addition and subtraction. We'll do that left to right as we come to it. Now we're going to look at problems involving decimals, though. 0.4 times, in parentheses, 8 minus 3.8. So we need to know how to do all these things with decimal addition, subtraction, multiplication, and division like we did today. Parentheses first. So inside we have 8 minus 3.8. Line up the decimals when we subtract. 0 minus 8 can't be done. Borrow. 10 minus 8 is 2. Decimal point to keep them in line. 7 minus 3 is 4. So that means that we have 0.4 and then times, because that's what parentheses means, times 4.2. We worked inside the parentheses first. That's why we did subtraction first, not because we're breaking the rules, but because the rules say work inside the parentheses using order of operations in there as well. And all we had was this one subtraction problem. And then we multiply. 4.2 times 0.4. 4 times 2 is 8. 4 times 4 is 16. 0 times everything would just be zeros. 2 places past decimal points, 2 places in the answer then. Our answer would be 1.68, which we say how? It ends in the tenths, hundredths spot. So 1 and 68 hundredths. Order of operations, same as last class, only now with more work. I would like to look at this one next. 0.51 plus 4.41 all over 3, and we'll see another one of these later in the review. This fraction bar is division. So we do the top completely, we do the bottom completely, and then we divide as the final step. Bottom's already done for us. It's just the number 3. On top, we add, which means we line up the decimals. Decimal point goes in the same spot in the answer. We get 4.92, and that is over 3. That means division. We're all good right off the bat because the outside is not a decimal. So bring the decimal point up and divide. 3 goes into 4 once. 3 goes into 19 6 times. That's 12. 3 goes into 12 4 times evenly. No remainder. 4 times 3 is 12. 12 minus 12 is 0. 1.64 is the answer here. So as long as we're doing our new decimal arithmetic correctly, we can get through any of these problems because we know the steps. Let's look at 7.2 minus 7.83 divided by 2.7 plus 9.6. Well, what do we do first? There's no parentheses. There's no exponents. So we look for multiplication and division from left to right, and ding, 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 there it is. So the first thing we do is going to be 7.83 divided by 2.7, which we're going to make 78.3 divided by 27, because we need to get rid of the decimal on the outside. 27 goes into 78. Will it go in 3 times? 27 times 3, carry the 2, that's 81. No, so only twice. 54. It's 24 left. Bring down the 3. 27 goes into 243 how many times? It looks big. Is it 9? 3, carry the 6. Sure is. 9 times evenly, and because that decimal point was there, 78.3, it goes straight up 2.9. That's not the whole answer, though. All of that was just to get the 2.9 right here. Around the 2.9, we still have 7.2 minus 2.9, and then plus 9.6. No more multiplication or division, addition or subtraction from left to right as we come to it, not addition, then subtraction. That will give you the wrong answer. It does not mean addition first, then subtraction. It means addition and subtraction left to right as we come to it. So next up, this subtraction problem. 7.2 minus 2.9 is 4.3. Plus 9.6 is 13.9. The area of a triangle. New formula. 1/2 times base times height. So here we're mixing fractions with decimals. The base is 7 meters. The height is 2.1 meters. So 1/2 times 7 times 2.1. And since this is area, our answer is going to be in square meters, because at some point we're doing meters times meters, base times height. Well, just like comparing, we want to turn the fraction into a decimal so that everything's the same. So 1/2 becomes 0.5, and then 0.5 times 7 is 3.5, and then 3.5 times 2.1 is 7.35 square meters.
Before we move on, let's say we have a triangle, height 7 inches, base in decimal form 4.7 inches. What is the area? Well, you have to know the formula for an area of a triangle. And the area of a triangle is 1/2 base times height, 1/2 times 4.7 times 7. Notice now we have fraction, we have decimal, we're multiplying. So let's go ahead and change 1/2 to its decimal form, 0.5. 0.5 times 4.7. There we go. Remember, the decimals aren't lined up on purpose. It just happened to fall that way. 5 times 7 is 35. Carry the 3. 5 times 4 is 20. Plus 3 is 23. 2 spaces past decimals in the problem. We need 2 spaces past decimal in the answer. So 0.5 times 4.7 is 2.35. And now we're multiplying that by 7. 2.35 times 7. 7 times 5 is 35. 3. 7 times 3 is 21. Plus 3 is 24. Carry the 2. 7 times 2 is 14. Plus 2 is 16. 2 spaces past decimal points. 2 spaces past decimal points. The area would be 16.45. Since this was inches times inches, area is in inches squared, or square inches. Let's do this one more time with another triangle. Again, it's going to be area. We're going to have a base of 5.8 feet. We're going to have a height of 2.4 feet. Remember, height goes from the highest point of the triangle to the same level as the base. It doesn't matter that this height is outside the triangle. It's still the height. Area equals 1/2 base times height. Area equals 0.5 times 5.8 times 2.4. You can pick any two and then multiply by the third. You don't have to go in order. I'm going to. 5.8 times 0.5, 0, carry the 4. 5 times 5 is 25, plus 4 is 29. 2 spaces, 2.9. 0.5 times 5.8 is 2.9. We're going to multiply that by 2.4. 2.9 times 2.4. 4 times 9 is 36. Carry the 3. 4 times 2 is 8, plus 3 is 11. 2 times 9 is 18. Carry the 1. 2 times 2 is 4, plus 1 is 5. And when we add 6, 9, 6, 2 spaces past the decimals are required. The area would be 6.96, this time feet squared. Square feet. Okay. Instead of triangles, let's take a look at a rectangle. .61 yards this way, 2/5 yards that way. Let's turn it all to decimals. We know 2/5 would be 4/10, would be 0.4. So 2/5 yards equals 0.4 yards. The area of a rectangle is length times width. 0.61 times 0.4. See, they don't line up. 4 times 1 is 4. 4 times 6 is 24. 1, 2, 3 spaces past decimal points means our answer, the area, is 0.244 yards times yards, yards squared, or square yards.
Finally, let's evaluate 1.7y minus 2 for y equals 2.3. We're evaluating, so we plug it in. Instead of 1.7 times y minus 2, it would be 1.7 times 2.3 minus 2. 1.7 times 2.3 gives us 3.91. Minus 2 gives us 1.91. Feel free to check that multiplication. And with that, that is the end of this topic. The topic is solving equations containing decimals. The objective in this topic is solve equations containing decimals. So the steps for solving an equation in X. If fractions are present, multiply both sides of the equation by the LCD of the fractions. If parentheses are present, use the distributive property. Then combine like terms on the left, combine like terms on the right, rewrite so that all of the variable terms are on one side and all of the constant terms are on the other. Get the X by itself, and then check your answer in the original equation. So with decimals, nothing's different. We don't have any fractions. We don't have any parentheses. We want to get the z by itself. We need to undo adding 0.9. We do that with subtracting 0.9. Whatever we do on one side, we do on the other. So subtract 0.9 from both sides. That leaves us with z on the left, and on the right, 1.3 minus 0.9 is 0.4. Check 0.4 plus 0.9. That does give us 1.3. So the problem checks. 0.17x equals negative 0.34. We want to get the x by itself. We want to undo multiplying by 0.17. We divide both sides by 0.17. So divide both sides by 0.17 just leaves us with x on the left. On the right, negative divided by positive is negative. 0.34 minus 0.17, well, we can't divide by 0.17. We can divide by 17, though, what we get by moving the decimal point 2 to the right. If we move it 2 to the right on the bottom, we have to move it 2 to the right on top. That's negative 34 divided by 17, which is negative 2. I leave the check to you. Let's kick it up a notch. We'll need to use both properties here. First, in order to get the x by itself, we need to get the entire 0.3x by itself. So we need to get rid of a positive 1.7. We do that by subtracting 1.7. Whatever we do on one side, we have to do to the other. 2.9 minus 1.7 is 1.2. So we have 1.2 equals 0.3x. Now we can get the x by itself by undoing, multiplying by 0.3. That's dividing by 0.3 on both sides. So 1.2 divided by 0.3. We can't divide by 0.3, but we can divide by 3. Move the decimal point 1 to the right. Whatever we do on the bottom, we have to do on top. So 1 to the right there makes this 12 divided by 3, which is 4. X equals 4. And once again, I leave the check to you. Eight x plus 4.2 equals 10x plus 11.6. So we want to start moving things around, getting the x's on the same side. We can start by subtracting 4.2 from both sides. That gives us 8x equals 10x plus 7.4. And if you wanted to do it the other direction, if you wanted the x's on the right side so that it would stay positive 2x, feel free to try it that way. You'll end up at the same answer. It could be good practice. But here we're moving the x's to the left. We're actually going to subtract 10x from both sides. 8x minus 10x gives us negative 2x's. Divide both sides by negative 2, and we get x equals negative 3.7. If you had moved them to the other side, you would have had negative 7.4 equals positive 2x. You still would have been dividing a negative with a positive to get negative 3.7. To get rid of the parentheses, we need to distribute that 3. 3 times x is 3x. 3 times 2.9 is 8.7. Let's subtract 6.3 from both sides. 8.7 minus 6.3 is 2.4. Let's subtract 3x from both sides. Negative 5x minus 3x is negative 8x. Divide both sides by negative 8. And we get negative 0.3. So even though decimals in equations are new, the steps for solving are no different. So we're becoming very good at solving equations by this point. 0.2y plus 2.6 equals 4. To get the y by itself, we need to get the 0.2y by itself, which means we need to undo adding 2.6, which means we need to subtract 2.6 from both sides. Even though we're getting good at the steps of solving equations, doesn't mean that working with decimals isn't annoying. Especially when we're doing it by hand. It would be a lot easier if we could get rid of the decimals before we did any of the other work. Let's multiply the equation through by 10 to eliminate the decimals. Why 10? Because the decimals end in the tenths spot. And a way to cancel out 1/10 is by multiplying by 10. So multiplying both sides by 10 means distributing the 10 on the left and multiplying the 10 on the right. Multiplying by 10 moves decimal points 1 to the right. So this becomes 2y plus 26 equals 40. And that we can solve no problem. Subtract 26 from both sides. 2y equals 14. Divide 2 from by both sides. Let's try that again. Divide both sides by 2. Y equals 7. I leave the check to you. This trick can work on getting rid of any number of decimal places. Always pick the largest number of decimal places for it to work. For instance, if there was a decimal that ended in the 100th spot, we would multiply both sides by 100. And that's it for this topic. Write the decimal number in words. For 21, we have 0.078. I had some people tell me this was hundredths, among various other answers. I can see why hundredths might get picked here. In normal place value, we go ones, tens, hundredths. Ones, tens, hundredths. But remember, that's not what happens over here. Over here, tenths is the first spot. Tenths, THS. And then hundredths. And then thousandths. This ends in the thousandths. How do we read this number? 78. That's it. You say the number and then you say the place value where it ends. So if you don't know your decimal place values, you can't get this right. And if you get it right, you're guessing. 78 thousandths, not 10 thousandths, not 100 thousandths, just thousandths. Number 22. Our old friend subtract blank from blank. Hello, subtract blank from blank, my old friend. We're going to subtract 0.0285 from 16. That means we're starting with 16 and we are subtracting from that 0.0285. How do we do this? Well, we line up the decimal points when we subtract. 16 is 16 point however many zeros we need. So 16 point however many zeros we'll need minus the 0.0285 decimals lined up. Oh, put that over. 16 point minus 0.0285, and now it's not cut off. How many zeros would we need then to make this look pretty? 4. There we go. Now it looks pretty. So I did manage to squeeze in one more zero subtraction problem in the decimal section. 0 minus 5. Can't do it. Got to borrow. Got to borrow over all these zeros. So that 6 becomes a 5. Skipped over zeros become 9s. 0 we started with becomes a 10. 10 minus 5 is 5. 9 minus 8 is 1. 9 minus 2 is 7. 9 minus 0 is 9. Decimal point in the space it goes where it's lined up. We do that for addition and subtraction, not for multiplication and division. 5 minus 0 is 5. 1 minus nothing is 1. So our answer, 15.9715. The only correct answer. How would we say it? Just for laughs. Where does it end? Tenths, hundredths, thousandths, 10 thousandths. So this is 15 and 9,715 10 thousandths.
23. We're going to multiply 0.58 times 0.7. Well, when we multiply, we do not line up the decimals. We write justify, just like an addition or subtraction problem with whole numbers. Most digits times least digits is how I set it up. The decimals, do not go out of your way to line them up, because this is not addition or subtraction. Even if they accidentally line up, remember, that does not mean it goes in the same spot in the answer. It most certainly won't if they end in the same spot. They actually cannot line up straight through question and answer. It's impossible. So basically, we're doing 58 times 7. And then there's going to be 1, 2, 3 places after a decimal point. 7 times 8 is 56. Carry the 5. 7 times 5 is 35, plus 5 is 40. Why don't I have to write anything else down? Well, because 7 times 0 is 0, and then 0 times everything is 0. Anything else written is going to be 0. 1, 2, 3. 1, 2, 3. Put a 0 there for fun if you want. 0.406. 406 tenths, hundredths, thousandths. 406 thousandths. So not 4.06, not 0.0406, not 0.00406, only 0.406. We multiplied, now we divide. In number 24. We're given 1.05 divided by 0.07. When we divide, we have one question we must ask ourselves when it comes to decimals before we can do anything else. That question is there a decimal on the outside? The answer here is yes. The response to yes is, well, make it so there's not, or you can't do it. So let's make it so there's not. How many places do we have to move the decimal point to the right? 1, 2. Whatever we do on the outside, we have to do on the inside, the exact same. We're not turning it into a whole number on purpose. We're just moving it 2 spaces because 2 spaces happened here. 1, 2. That just so happens to turn it into 105 divided by regular old 7. Ask yourself again, is there a decimal on the outside? The answer is no, which means wherever the decimal has now fallen inside, we take it directly through top to the answer. That's all there is to that. And now it is just a regular division problem. Because this is a decimal problem, if there's a remainder, we cannot put it in remainder form. We have to continue this problem till it is completely done by putting in zeros and bringing them down if necessary. But not necessary, because 7 goes into 10 once, and around the corner 1 times 7 is 7. 10 minus 7 is 3, bring down the 5. 7 goes into 35 5 times evenly. No remainder, no need for a 0 to bring down. The answer is just plain old 15, not 1.5. Number 25, order of operations with decimals. 0.22. plus 2.45. All divided by 0.3. So we add first 0.22 and 2.45. I just feel better putting the big number on top. It doesn't matter though. Decimals in line because we're adding. So decimal in the same place in the answer. 5 plus 2 is 7. 4 plus 2 is 6. 2 plus 0 is 2. 2.67. We're not done though. We have to divide that 2.67 by 0.3. We simplified the top. Now we have number divided by number and we have to do it. So, a couple ways to think of this. When we see something like this, the bottom number is the same as the outside number. So we have to turn the bottom number into a whole number. Whatever we do on bottom, we do on the top. 1 space, 26.7. So again, we don't go 2 spaces on top just because that turns it into a whole number. Top doesn't have to be a whole number. Bottom does. 1 space for that has to match 1 space on top. So we're going to end up doing 26.7 divided by 3. I'm going to move that up a little bit because I think we might need it for all I know. But you could also just do it consistently like we did the last one. When we see top over bottom, we know that's 2.67 divided by 0.3. Ask ourselves the question on the outside, do we have a decimal? Yes. Well, fix it. Okay. How many spaces do we need to do it? 1. So we only move 1 on the inside, which gives us 26.7 divided by 3. Is there a decimal on the outside now? Nope. So wherever the decimal landed on the inside, it goes straight up into the answer in the same spot. 3 goes into 26 how many times? 3 times 8 is 24. 3 times 9 is 27, which would be too much. Multiply around the corner. 8 times 3 is 24. Subtract. Oh, we get 2. Bring down the 7. 3 goes into 27 9 times evenly. No need for additional zeros to bring down because we have a remainder of 0. We have our answer. 8.9. Not 0.089, not 89, not 0.89, 8.9.